In this video, we will discuss the closed interval method. Closed also means bounded in this case, right? By our discussion before, if you have a function, f here is continuous on a closed bounded interval AB by the extreme value theorem. So f attains the absolute maximum value and absolute minimum value at a pair of numbers, right, inside AB, including could be A or B, right? So let's try to use this method to identify them, right? So this is a method you can use to identify the extreme value of a function which is continuous on a closed interval, closed and bounded interval, right? So what do we do that, right? So our goal here is for sure to find the absolute maximum. Okay, just use extreme values of f on the interval AB. We just need to do the following steps, right? Step 1 here is find, because inside AB, if you have a local maximum or local minimum, that should be that at a number, that number will be a critical number, right? So find the values of f at critical numbers inside AB. 2 here is find f of A and f of B. As we discussed, the extreme value could happen at local maximum, local minimum, also could happen at the boundary point, the terminal point of the interval, right? So then you get lots of numbers. The third one here is pick the maximum of them. So the absolute maximum value of f is the largest number in 1 and 2. And the absolute minimum value of f is the smallest number in 1 and 2, right? Basically, so that's how do we identify the extreme function value if the function is continuous, and also the domain we are interested is closed and bounded. So let's see an example. We have a function f of x equal to 2x cubed minus 3x squared minus 12x and plus 1, right? So that's a polynomial function. And domain here is from -2 to 3. So this is our D domain, right? So we want to find the extreme values of f on D, right? We are looking for the absolute maximum value and the absolute minimum value of this function uh, inside the interval, on this interval from -2 to 3, right? So let's try to do that. Step 1, looking for the critical numbers in AB and find their values, right? So critical numbers are the numbers make the derivative to be either a 0 or doesn't exist, right? So let's try to get the derivative. So f prime of x clearly is 6x squared minus 6x minus 12, right? So that's it. Okay. We are looking for the numbers which make this one does not exist or equal to 0. This is a polynomial. This function value always exists, right? This derivative always exists. Then we are looking for the numbers which make this to be 0. And to do that is easier to factor this, right? So 6x squared minus x minus 2 equal to 6x minus 2 x plus 1, right? So you get the critical numbers of f inside -2 and 3 is either 2 or -1, right? If you have some number outside of the interval we are interested, then don't worry about that. But 2 and -1 are both inside. And so now let's try to calculate the function value at the critical number, right? F of 2 and f of -1. So this is 2 times 2 to 3 minus 3 times 2 squared minus 12 times 2 plus 1. And if you do a calculation, this is -19. And so this is 2 times -1 to the power 3 minus 3 times -1 squared minus 12 times -1 plus 1. So if you try to simplify the number, you get 8. Now we have the function value at the critical numbers inside D. Now we want to get the function value at the endpoint, right? So when endpoints are 2 points, either 2 or 3 or -2, right? When x equal to -2, f of -2, so this plug in all the number, this will be -3. So when x equal to 3, f of 3 is -8, right? Okay, now you can see that we have 4 numbers. They are all different, right? The biggest one, the greatest one, the absolute maximum value. The smallest one will be the absolute minimum value, right? You can see that the biggest one is 8, and the smallest one is -19. So this is the absolute maximum value of f on D. So this is the absolute minimum value of f on D. So that's how do we identify the absolute maximum and the absolute minimum value given a function to be continuous on a given domain too, right?